and we have f prime. So of course I'm considering this f of x. F of x and f double prime. Can anyone give us a domain, please? Please follow me, pay attention, and answer, please.
Negative infinity to 2, 2 to infinity.
Excellent. Thank you so much. In other words, what Kaylee was telling us is she said 2 is not in the picture because the denominator will be 0. Also, 0 has to be in the table. So I see that these two are 0 and this one is 0. So what will be the value of the function when x is 0? And I will put it in right here. Yes, so it will be negative 1/2. Good. Now we have to determine this limit, this limit, this limit, and this limit, and see if this function can be 0. When I set this fraction equal to 0, if this equation has solutions, what has to happen? When is a fraction 0?
When the numerator equals 0.
Excellent. 1 plus 5x minus 2x squared equals 0. Yes, I will arrange it in the correct order. 2x squared minus 5x minus 1 equals 0. I will share my screen and put it in the graphing calculator in apps and number 9. So this is degree 2. I want the coefficients 2, negative 5, negative 1. No, I want 2. I want negative 5. And I want negative 1. So are the solutions imaginary? No, they're not. So then we have x equals negative 0.2 and x equals 2.7. Very good. So 2.7 is right here. And negative 0.2 is right here. And I put them in the table where they belong. So please understand, many of you did not create the table correctly, did not evaluate, did not put all the values. You have to put all the values in here because this is what we graph. X comma y, x comma y, x comma y. I know that x equals 2 is a vertical asymptote. How do I know? Because I would not be able to simplify x minus 2. If I had gotten x equals 2 here, I would have said, oh, I can factor this into x minus 2, but there is no way. We cannot. Okay, so I would like to determine the limit from the left and the limit from the right. So limit as x approaches 2 from the left from 1 plus 5x minus 2x squared over x minus 2. I know for sure it must be an infinity, but what I don't know is the sign. And the other one the same, 2 from the right, 1 plus 5x minus 2x squared over x minus 2. I know it has to be infinity, but I don't know the sign. So I have to plug in, and this is 1, this is 10, so this is 11. This is 4 times negative 2. So 11 minus 8. So the top is always positive for both. So the top will not give us the sign. We shouldn't even waste our time with it. So one more time, 4 times 2 is negative 8, but this is 11 minus 8. So it's positive. So now let's plug in a number from the left of 2 and give me the sign here, and then a number from the right of 2 and give us the sign here.
Is the first one negative?
Yes. First one is negative because 2 from the left will be 1.9. 1.9 minus 2 will be negative. Positive over negative is negative. Excellent. What about here?
Positive.
Thank you very much. Positive indeed. Good. Final step, this. This is connected to either horizontal or slant asymptote. So let's analyze. Does this function it cannot have a horizontal and a slant. Not possible. Either horizontal or slant. So can anyone tell us whether this function has a horizontal asymptote or a slant? Of course, it can be this or this, but the horizontal is horizontal. Does this function have a horizontal asymptote or a slant asymptote? And why?
Slant.
Slant, okay. Why?
Because the degree is 1 more.
So the numerator has degree 2, and the denominator has degree
1.
Exactly. When I divide degree 2 by degree 1, I will get a line. And you can say, but the horizontal asymptote is still a line. Yes, but what I mean is an oblique line, either this way or this way. And then, once I determine this, the slant asymptote, I will know the limits. I don't have to write them again. How do I know? How do I know? So if it's this, I will write negative infinity, positive infinity. If it's this way, then I will write positive infinity, negative infinity. Because the function has to follow the asymptote. So let's find the asymptote. What would you like to use? A long division or the synthetic division?
Long.
Okay, so let's use the long division. For the long division, please remember everything has to be correct in the correct descending order. Negative 2x squared plus 5x and plus 1 and divided by x minus 2. X times what is this? What should I write at the top?
Negative 2x.
Very good, awesome. Negative 2x times x is negative 2x squared. Change the sign, positive 2x squared. Distribute, continue to distribute. Positive 4x, change the sign. 1x plus the next in line. X times what is x? At the top, we don't lie. When we distribute it, we come back underneath, we change the sign. So x times what is x?
1.
Yes, positive 1, very good. So then distribute. 1 times x is x, now change. 1 times negative 2 is negative 2, change. Box it in. So what does this mean? It really says that negative 2x squared plus 5x plus 1 divided by x minus 2 equals, what is the quotient? Plus.
Negative 2x plus 1.
Very good. Negative 2x plus 1. What is the remainder?
3.
Yes. And what is the divisor?
X minus 2.
Of course. Thank you very much. So now see what happens if I apply the limit to infinity to the function. This will be 0. If I apply the limit to negative infinity of the function, this still will be 0. So that's why it doesn't count. So can anyone give us the slant asymptote?
Negative 2x plus 1.
Awesome. This is it. Now look at this line and tell me whether it has a positive slope or a negative slope.
Negative.
Negative. So this is where the function is going. this way to positive infinity and this way to negative infinity, you don't have to determine the limits again, because it has to follow the function. So the slant asymptote, I meant to say. So I write myself a note, y equals negative 2x plus 1, slant asymptote, so I don't forget. It will be crucial. I cannot forget that. That's why I put everything in the table, so I don't have to look anywhere. So at this point, we exhausted everything about the function. We have the x and y intercepts. We have the limits left and right of the vertical asymptote. We determine the end behavior based on the slant asymptote, infinity, negative infinity. So we have all the information. There is nothing we can learn, nothing else we can learn from the function about the function. Now I have to move on to the first derivative. Do we understand these steps so far, everyone?
Yep.
Thank you. So now we continue with the first derivative. Ugly, but we have no choice. So this is our function. So then f prime of x minus 2 squared. Top prime, negative 4x plus 5 times the denominator minus the top times the denominator prime. Luckily, it's just 1. Yay! Okay, so let's see. Negative 4x squared, positive 8x, positive 5x, and minus 10, plus 2x squared, minus 5x, minus 1. X minus 2 squared. Please make some go away, please. Let's see if my wishes are heard. At least a little bit. So negative 4x squared with positive 2x squared, negative 2x squared. The 5x with the minus 5x, but I still have an 8x. And the negative 10 minus 1 is negative 11. Yes, of course, I don't like a negative leading coefficient. Over x minus 2 squared. Okay, I found the first derivative. What will I need to determine next? After I find this first derivative, what do I do with it?
Is it the domain?
We had to find the domain from the very beginning. So we had to find from the this is the very first step. When we said, what is the domain? And the domain is every possible real number except the value of x that makes the denominator 0. And we established that from the beginning. But what I think you have in mind is find critical numbers, and they come from two sources, from f prime of x being undefined and from f prime of x being 0. But it happens that this function is undefined exactly where the original function is undefined, so no critical numbers will come from undefined. Okay, so from f prime being 0, I have 2x squared minus 8x plus 11 divided by x minus 2 squared equals 0. You already told me that a fraction is 0 only. You said that a few minutes ago, when 2x squared minus 8x plus 11 is 0. So let's see. I'll put it in the calculator again. Oops. So, yes. Yes. But the coefficients are 2. Yes, that's okay. Then negative 8. And then 11. and solve. Ha! Okay, very good. So if no real solutions, I need to check so that just to make sure I entered that correctly. So 64 minus 4AC. Yes, it is true. Correct. So no real numbers, no real solutions. Fine. Which means this is always positive. There is a minus in front, but this quantity is always positive. Always. But so is this. But there is a minus in front. So what will you say about the derivative? The top is always positive, the bottom is always positive. No critical numbers coming from here. None whatsoever. Which means no max min. Immediately I know that. No max, no min. If there are no critical numbers. And if I find critical numbers, there is no guarantee. I have to check. So then what will be the sign of this derivative forever?
Negative.
Very good. Okay, so now the moment of truth. This is when I check and I find potentially mistakes. If these two rows don't work well together, then I'll say, uh-oh, and I have to go back to the drawing board. So it has to decrease forever. I will see. From positive infinity to 0, yes. From 0 to negative 1/2, yes. From negative 1/2 to negative infinity, yes. So far, so good. From positive infinity to 0, yes. From 0 to negative infinity, yes. So these two rows are perfect. Now this is a mess. Why? Because it's not a nice function to work with. But we will get there. So I'm going to copy f prime. Let me start a new video.